Good morning, everyone. My name is Delaney Drew, and I'm a MD, MPH candidate at St. George's University. This is my capstone project. First, I want to say it's a pleasure to be here speaking to you about this topic, and I appreciate your attention and your time. Secondly, I'd like to I know acknowledgements at the end, but I want to give a shout out to Dr. Mitchell, my advisor. I think he knows this more than anyone. This would not have happened without his help. So appreciate his guidance. And I think without further ado, we'll get started. So my topic is particulate matter air pollution, specifically particulate matter 10 and 2.5, and skin disease, a narrative review. So this is the abstract. I'm gonna just move forward, but you can obviously take a pause and read this over if you're interested. So my research question basically is particulate matter air pollution associated with incidence of skin disease. And here are my null and alternative hypotheses. So a little bit of background. I think it's not uncommon knowledge that air pollution is dangerous. But I think people are unaware of how dangerous it can be. So air pollution kills about 7 million people in the last year, 6.67 specifically. And you can see this chart from the WHO. This is from the Status of Global Air 2020, showing that air pollution is up from last year, where it was the 5th leading cause of death globally. Now it's the 4th leading cause of death globally. And that doesn't account for the billions of people that are affected by it on a day-to-day basis. So the burden of air pollution is severe and growing. So this is kind of what I was talking about, that State of Global Air 2020. And it's an annual collaboration between the Health Effects Institute and the Institute for Health Metrics and Evaluation. And their report, in addition to other things, says that 99% of the global population live currently in a place where the air quality is below WHO guidelines. So a significant amount of our population is dealing with the harmful effects of air pollution. And it's very well documented that the global burden of disease of multiple big heavy hitter diseases are exacerbated by air pollution. Stroke, heart disease, lung cancer, acute and chronic respiratory diseases, COPD and asthma, diabetes, and even the fetus. So it's a widespread effects of air pollution. So the physiological dangers of air pollution have been documented since 1991, following a study out of Japan by Miyamoto. And he basically connected this Japanese cedar pollinosis, which is a respiratory illness, with the increased prevalence of diesel cars. And since then, the body of research has only expanded exponentially to include all of those diseases I had mentioned before. The specific scope of this paper is on skin disease. And maybe not surprisingly, skin disease hasn't really been at the top of the list for concerns with regard to air pollution. And a lot of the times it's left out of the numbers with regard to the burden of disease of air pollution. So, well, let's move forward. So what about skin? And I kind of mentioned this, the current reports don't include skin estimates, but skin, the budget of, so in 2004, I'm sorry, the total economic burden of skin disease in general was $96 billion. This was before this is not a, this is just in general. So skin is a large chunk of change with regard to how much the US is spending. And this burden of disease is only exacerbated by the visibility of dermatological diseases. I think most dermatologists would tell you sometimes the effects of the diseases they're seeing are not being able to sleep from itching all night, social anxiety, social issues, not being able to go outside because of embarrassment. So the burden of skin disease is hard to measure. Additionally, we will need to consider the reduction of family income due to inability to work, increased healthcare expenditures, and then according to one study, at least a quarter of the population suffer from a skin disease at one time, at any one time. So this is a significant amount of the population who is experiencing skin-related issues. And while obviously more research is needed in this area, it's clear that we are underestimating the current burden of disease with regard to air pollution and skin disease. So current reports definitely underestimate the air pollution and dermatologic burden of disease. Why though? So it makes sense to us considering the skin's main function is to protect the internal organs from physical damage. So it would make sense, especially in addition, considering the surface area of the skin and it being the main line of defense against air pollution, that it would have harmful effects. And so on the left here, we have a table of the functions of the skin. And we learn a lot in school about how the structure of a system dictates its function. So imagine if we're alternating the structure of the skin through this damage, what are the other functions of the skin that we will lose as a result of that? And then one study, one review explained that when we have prolonged or repetitive exposure to toxins, that this exposure can exceed the skin's defensive potential, and that leads to a decrease in the skin barrier function, and then ultimately leading to infectious, allergic, and autoimmune skin diseases. So this is just a little bit about the in vitro proposed mechanisms of skin disease, generation of free radicals and oxidative damage. Just a little bit of background, but one of our studies did find that we have an increased transepidermal water loss, which is a measure of the skin's barrier function. And issues with transepidermal water loss are significantly associated with periods of high particulate matter. So we are seeing in the review, and we'll get to this later, but I just want to mention that this kind of is in line with what we were seeing. So this is a little bit about the mechanism. We have some barrier dysfunction leading to inflammation, oxidative stress, and then it kind of exacerbates in a snowballing effect. So next, or some of the background, I want to talk a little bit about particulate matter. The WHO subcategorizes air pollution into 3 subcategories, all based on how harmful they are to human health. And for this particular study, we're going to ignore ozone pollution and partially ignore indoor air pollution and mostly focus on the ambient air pollution outdoors. And for our definition, we're going to include not only PM particulate matter 10 and PM2.5. And so PM, both of these are referring to the size of the particles. PM10 is bigger, 10 micrometers, and PM2.5 is much smaller. And recent studies from the WHO have shown that the ambient 2.5 particulate matter is the most consistent and robust indicator of mortality. So a major source of PM include automobiles, factories, power plants, refuse incinerators, construction, fires, windblown dust. And the most dangerous of these are traffic sources. And that's because this can serve as a carrier for other organic chemicals and metals. So one of the unique features of particulate matter is that it can hold on to smaller particles. So anything that is a pollutant that is smaller than the 10 or 2.5 is something that can be carried on particulate matter and thus create a more harmful effect when inhaled or coming in contact with the skin. So this is just our objective, and it's a narrative review to summarize and give an update on the current data. And then the results of this can help guide further policies, research, et cetera. And I thought this was a nice picture, and I apologize for the cutting off of the side, but this is a indication of size and kind of where we are with regard to the particulate matter. On the far right, you can see this human hair, and the hair is giving you a size comparison. You move down about halfway through, you see grain of pollen, dust particle. That's the first PM, PM10, and it's only slightly bigger than the red blood cell to its left. And so moving down a little bit farther, you see the PM2.5 on the other side of respiratory droplet. So if you're thinking anything that's smaller than these, this wildfire smoke, respiratory droplets with regard to PM10 can all be carried on in dust particles. So kind of complicating the picture to particulate matter. So we'll move on to our methods. Again, this is a narrative literature review, and our search started off with a PubMed particulate matter and skin search, which returned 2,821 items. Our exclusion criteria, we wanted everything in the last 10 years, English language, we wanted anything across the globe, all inclusive. And then that was done by our automated PubMed screening. And then for our titles and abstract screening, we wanted primary research, excluding all reviews and qualitative research. We also excluded other forms of air pollution like cigarette smoke, ozone, dust. And it wasn't because we didn't want to include these, but we wanted to focus specifically on PM10 and PM2.5. And some of these studies also included other forms of air pollution, but as long as they included PM10 or PM2.5, they could be included in this study. Other studies we excluded were in vitro studies, infectious skin diseases, non-skin related conditions, animal studies, and those studies only considering indoor air pollution. So here's my Prisma diagram, kind of showing you starting with our PubMed search, where we excluded 2,173 based on the table 2.1 removed by automation, and we gathered 8 references from reference list screening. And after reviewing for eligibility, we ultimately ended up with 26 references included in our final study. So for our quality assessment, we use multiple systematic protocols in order to strengthen the findings of our narrative review. The first was a Hawker score, and that was more used to assess the strength of each individual study, ethics, bias, sampling, etc., all based out of 36. And then when we were assessing each group of resources based on diagnosis, we would use this secondary, it's called the guide from the U.S. Department of Health and Human Services, used to grade evidence essentially based on the criteria listed there. So there's additional information and the rubrics are at the end of the study. But I just want to briefly mention our quality assessment tools. So moving on to our results, we had 26 studies at the end of our final analysis. These included 10 from China, 6 from Korea, 3 from Japan, 2 from the United States, 1 from Brazil, 1 from Germany, 1 from Lebanon, 1 from Iran, 1 from Italy, 1 from Portugal, 1 from Tasmania, and 1 from Turkey. And 90% of these studies addressed a specific disease state. So 24 addressed a specific disease state. And the others addressed just skin changes with regard to healthy skin. So we included those as well, although they weren't specific to any disease state. From the included studies, over half addressed atopic dermatitis or eczema. Only 3 studies then were found that addressed both acne and 3 additional that studied skin cancer. And then we also had healthy skin, which had 2 studies, urticaria, which had 1 study, lentigo and seborrheic keratoses, both which are related to aging. Those both had 1 study, and psoriasis, 1 study, chronic skin ulcers, and systemic sclerosis. So 23 of the 26, no, I apologize, 3 of the 26 addressed children, while the rest specified no age bracket. And I'm seeing now that this chart is a little bit blurry, but this is basically a summary of our characteristics, kind of giving you what the study period was, where it's from, a list of diagnoses, and then the sample size and age brackets. So this next summary table is by diagnoses. So the first list are skin diseases that this narrative review deemed associated with particulate matter. And at the very right side of the screen, it kind of shows you the strength of the evidence. And this column is based off of the guide that I had mentioned previously in the methods about evaluating evidence. So based on the guide's recommendations on evaluating evidence, we have AD eczema with a strong evidence. And then at the very bottom, we have 3 diseases that showed insufficient evidence in a negative way, meaning that the results said that they were not related, but that evidence wasn't strong enough. So insufficient, negative association. And then for the bottom 2, urticaria and lentigo, we had a positive association, but insufficient evidence. And then for acne, damage to healthy skin, and chronic skin ulcers, we did have sufficient evidence, not strong evidence, and also that evidence was a positive association with particulate matter. Okay, so additionally, I want to address some themes and trends that popped up throughout the different studies. So the first one, epidemiological research. During our exclusion period, we noticed 3 main categories of particulate matter skin research. One was the epidemiological research, which were all the studies we included. The second, which were excluded, were in vitro studies, more dealing with the mechanisms of damage. And the third was treatment or preventative based studies. So the treatment and prevention and the in vitro studies were both excluded, but I think it's important to mention that in the realm of particulate matter skin research, those are also large areas currently having attention. The second theme that's extremely important is the complexity of particulate matter with regard to its different sizes, its carriers, its density and location dependent nature make it hard to measure, and also require several ways of measuring. For example, because particulate matter can carry so many different other pollutants, we need measures to not only assess particulate matter, but assess the components of particulate matter. Some of those studies included other ways, and others only focus on particulate matter, but definitely a new theme arising in particulate matter research is focusing on both the particulate matter as a whole and those potentially more dangerous components like the heavy metals and nitrous oxide and sulfate and carbon dioxide. Additionally, the third theme was temporality and symptom onset. So it depends on the disease state, but especially for atopic dermatitis, having what studies are calling lag time for symptom onset is important in order to catch the association between particulate matter and these disease states. Additionally, for cancer, you're going to need a much longer lag time. So this was something that we saw in almost every study again, just the necessity of considering how much time do we give these this relationship to show itself. Additionally, many studies included meteorological data in order to control for confounding. There's a significant relationship between weather and symptoms, but also weather and particulate matter. So because weather can influence both, it was important for studies to control for meteorological data for confounding and bias and just consideration. And then finally, a significant number, I would say about a quarter of our studies address vulnerability data. For example, studying children, studying geriatric population. Two studies addressed women being more vulnerable to certain pollutants, which again, just highlights the importance in medicine of when we're addressing these preventative measures, who is most at risk? The urban population? Is it those living closest to coal production? Is it Californians and wildfires? So definitely addressing those most at risk. Okay, so moving forward, I apologize, we're getting into the discussion now. So 9 of our studies specifically compared PM10 and PM2.5. 2 found no association. One was a psoriasis study, and another was an acne study. A third study found a higher association with PM10 than acne. And then the rest of the studies, 6 of 9, found a statistically significant evidence of PM2.5 being more deleterious than PM10. So that's something that the WHO's the status of global air mentioned as well, that PM2.5 is significantly more harmful than PM10. And so our study agreed with that. And it also agreed with a meta-analysis from 2017 that also found PM2.5 to be more dangerous. I think more research is needed in this, but also more research is needed to hone down into the components of PM2.5 and PM10. And then again, this picture on the left is just giving you a comparison to conceptualize the sizes. Okay, so our next finding discusses the components of PM. So the picture on the left kind of shows you some of the things that can be bound to particulate matter. So 7 studies found significant relationships between skin diseases and PM-contained pollutants, specifically gaseous pollutants like carbon dioxide, nitrogen dioxide, sulfur dioxide, ozone, and benzene. And each of our studies showed various degrees of connection with skin manifestations, but more research is absolutely needed. So we had one study identify sulfur dioxide and nitrogen dioxide as contributors to PM-mediated skin disease. Another identified nitrogen dioxide. A third, also 2 others identified nitrogen dioxide, and then a fourth associated a benzene exposure with psoriasis. So there's definitely room for more research moving forward to flesh out the strength of these associations. And again, these findings are consistent with the mechanisms that I discussed earlier with regard to oxidative damage and exposure to particulate matter. This is just a quick picture I found about other types of pollutants that can be kept on or can be bound to particulate matter. And I realize it's kind of hard to read the small writing, but more importantly is just the big names, like how many different things can be included in one measure of particulate matter that we may or may not be accounting for when we're only measuring particulate matter in general, if that makes sense. A final finding was an association between UV light and particulate matter. 2 of our studies particularly addressed this, which is consistent with other findings in reviews that UV light exposure is a contributor to skin barrier dysfunction. And another study that suggested that not only do they are they both damaging to the skin, but they are synergistic in nature, in that polycyclic aromatic hydrocarbons, which are one of those many things that can be contained within particulate matter, can work synergistically with UV light to create more oxidative damage and thus be more harmful. So again, more epidemiological research is needed in this area. So I want to just discuss the strengths and limitations of this study. The narrative nature of this study allows for us to address the development of a body of work as it's moving. The research in air pollution is extensive and growing. And so being able to track the status and where we've been and where we're going is a strength of the narrative review. Additionally, the narrative review allows for a large scope. We were able to include a significant range of studies and ultimately a significant number of cases of PM exposure were evaluated. And then additionally, which I mentioned earlier, we used multiple standardized protocols throughout, for example, PRISMA, Hawker scores, and the guide in order to strengthen the studies at the end, our end result. Some limitations of our study is that the data collection and the primary screening were done by one author, which could have led to exclusion of relevant articles. And to account for this, both authors set a predetermined selection criteria in order to kind of make sure we don't miss anything. Additionally, exclusion of the prevention and in vitro studies could have limited some of the knowledge we gained. Additionally, I want to address any cultural biases. We included global studies from across the globe, which is important, but additionally, reading these studies as an American researcher can lead to not necessarily misinterpretation of findings, but better understanding of other US-based studies, while more foreign studies might not be as straightforward. For example, knowing California is prone to wildfires, whereas some studies from different parts of the world used geographical maps to indicate PM exposure. And so having a general knowledge of that country, its norms, its cultures, its geography, could potentially put a limit on your ability to comprehend those studies, especially in comparison to those from places you're more familiar with. And then additionally, there's a air pollution measurement bias that needs to be mentioned. The ability to measure particulate matter across the globe, there hasn't been one standardized way of measurement. Additionally, when you're measuring it, it's only a mean measure and not a measure of direct exposure. So if you're measuring for a certain area, we're not sure whether the individuals in that community actually had that level of exposure. We're only able to give a rough estimate. So that's another potential issue. Additionally, which I mentioned before, not being able to measure those components of particulate matter can add another level of bias. So in conclusion, based on our epidemiological findings, it's safe to say atopic dermatitis and eczema it's strongly associated with both PM10 and PM2.5. The other diagnoses we discussed, skin cancer, acne vulgaris, chronic skin ulcers, and damage to healthy skin, those are sufficiently associated with PM in general, but we don't have enough evidence to suggest that they're more related to PM10 or PM2.5. And then finally, 3 diagnoses, lentigo, psoriasis, and systemic sclerosis showed insufficient evidence for association with particulate matter, and for further studies are needed in both those final areas. So just quickly to discuss the practical implications of our research. So researchers specifically should focus on identifying the most harmful components of particulate matter, finding more standardized ways of measuring the components and air pollution in general. Additionally, elucidating the impact of particulate matter on non-atopic diseases. There's significant research, a significant percentage of the research focusing on atopic diseases, so exploring outside of that disease state is an important area. Additionally, evaluating current particulate matter interventions and identifying whether they're leading to the wanted objective is important. Is our money being used appropriately? So future policy should be aimed at monitoring and reducing the most harmful components of particulate matter. If we're focused on reducing PM10 and it's not the most harmful, we should know that. So moving forward, identifying which of those is most harmful and realigning policies to match our new knowledge. This review should also prepare practitioners for an increase in PM-related diseases, especially considering the worsening global climate crisis, including wildfires, natural disasters, etc., increasing pollution. Other additional areas for research include identifying indoor versus outdoor air pollution. indoor air pollution just quickly relates to like stove coal burning on the inside, which is very popular in African and Asian countries. Additionally, the concentration and duration of exposure, so those living or working more closely with toxins are more harmful or at a higher risk. And then again, as I mentioned earlier, the evaluation component of our policies and procedures. So conflicts and interest, we don't have any to discuss. And then again, I just want to thank Dr. Mitchell for all of his help and guidance. And some references. And then this additional information, this is just an example of one of the evidence tables that I used to collect, to assess the evidence. So I wanted to include that. And then finally, these are the rubrics for evaluating evidence. And this is the Hawker score, which was the out of 36 points. And of the 48, only 26 were eligible based on Hawker score. So if you were under a score of 18, you were eliminated just based on length of strength, not having enough strength in your study. Well, I thank you for your time. I appreciate your attention, and thank you very much.